This question says that a tourist attraction in a city center is a big vertical wheel on which passengers can ride. The wheel turns in such a way that the height h meters of a passenger above the ground is given by this formula. Okay, let me just draw a Ferris wheel. Let's say this is the Ferris wheel in question. Okay, so the height h of the passenger above the ground is given by the formula. So we all know how Ferris wheels work. So at every point, the passenger will be on a different height. And this height is modeled by this given equation. Height equals 60 times 1 minus cos kt. It's very common to model periodic functions using cos or sine equations. Periodic function means that this height keeps increasing and then decreasing, increasing, decreasing. So it's going to be a wave kind of motion. The height increases and then it decreases, then it increases again, then it decreases. That's why it's being modeled by a trigonometric equation. Okay, so in this formula, K is a constant and T is the time in minutes that has elapsed since the passenger started the ride. So for example, at T is equals to 10, there will be a particular height. At T is equals to 12, there is going to be a particular height. At T is equals to 15, there's going to be a particular height. So at every time, at every value of T, there's a different height. Okay. Since the passenger at Acha. T is the time in minutes that has elapsed since the passenger started the ride at the ground level, and KT is measured in radians. Find the greatest height the passenger uh, can move above the ground. Okay. Greatest height just means that we need the largest value of the range of this equation. Okay. How do we find the range? This can have a maximum value of 1 and a minimum value of -1. So height will be maximum when we choose -1 over here, because then we'll get 1 minus -1, which would be 2, and then 60 times 2 is 120. So 120 is going to be the maximum height a passenger can attain while sitting on this Ferris wheel. Okay. Next part says that one complete revolution of the wheel takes 30 minutes. So it takes 30 minutes for a passenger to start from here, go all the way up, and then all the way down. Okay. Show that k is equals to 5 pi over 15. Okay, so one complete cycle of this Ferris wheel takes 30 minutes. One complete cycle of a cos graph takes 2 pi radians, right? This is 2 pi radians. So what I'll do, I'll equate 2 pi to this value. This value is related to the period of the graph. Okay. Now we already know the value of t. It is 30. I'm going to replace t with 30. So k is equals to 2 pi upon 30, which gives k is equals to pi upon 15. That's how we get pi over 15. We equate the period to the value in the equation that represents the period, which is always the input of cos. So that's going to be kt, and t is already given in one complete revolution. It's 30 minutes. So that's how we get pi upon 15. Next part says, find the time for which the passenger is above the height of 90. Okay, this was a height of 120. Let's say height of 90 is somewhere over here. If passenger is here, the height is 90. Or when the passenger is here, the height is 90. That means the passenger reaches this height twice while moving in the Ferris wheel. So between this region, the height is going to be above 90. So what we'll try to do, we'll find the time taken to get the height of 90 for the first time, and then we'll try to find the value of t when again the passenger reaches a height of 90 meters while going down, and then we're going to subtract these two times. Okay, so the height is 90. I'm going to equate the height to 90. 90 is equals to 60. 1 minus cos. K is already known, pi upon 15. And t is what we have to find. We'll probably get two values of t from this equation. And then we're going to subtract those two values of t. Okay, we get 1.5 from 90 divided by 60. 1 minus cos pi by 15t. Now I'm going to make cos the subject. I get 1 minus 1.5, which is minus half or minus 0.5. Cos is negative. In the second quadrant, add sugar to coffee, and the third quadrant. Now I need the absolute angle. Absolute angle is going to be cos inverse half. And remember, we still have pi t upon 15 left here. Okay, so cos inverse half is 1 by 3 pi. So we get 1 by 3 pi here and 1 by 3 pi here. That gives us the actual angle pi minus pi by 3 and pi plus pi by 3. So we get pi minus pi by 3 is 2 by 3 pi. And pi plus 1 by 3 pi is 4 by 3 pi. So now I'm going to equate this to both of these values. Pi t upon 15 equals 2 by 3 pi and 4 by 3 pi. Okay, cancel the pi's. So we get 2 into 15 divided by 3. We get t is equals to 10. And pi's get cancelled. 4 into 15 divided by 3 is 20. So that means first time the passenger reaches the height of 90 is going to be in 10 minutes. Second time the passenger reaches the height of 90, that's going to be 20 minutes. And the time for which the passenger stays above the height of 90 is going to be 20 minus 10, which is 10 minutes. So between these 10 minutes, the passenger will be over 90 meters high.